All right, let's dive in. Today, we're talking about a database that honestly was a game changer for so many of us developers, MongoDB. You know that feeling, right? When you've got this complex, real-world data and you're trying to cram it into these rigid little tables. It's a pain. So we're going to explore how MongoDB basically said, nah, there's a better way, and broke free from that whole world of rows and columns.
So for like decades, the rule was simple. Data lived in these super neat, orderly tables. Just think of a spreadsheet. That was the relational database world. But let's be real. Modern data, it's anything but neat. You've got social media feeds, data from your smart home gadgets, crazy complex user profiles. It's messy. It's nested all over the place, and it's always changing. The old rules, they just don't cut it anymore.
I mean, come on, how many of us have been there? You're nodding along, I can feel it. You've got this beautiful object in your code, it makes perfect sense, and then you have to perform what feels like data surgery. You're just breaking it all apart, flattening it out, all to make the database happy. It's so awkward, and it's just not efficient. And that frustration, that is the exact reason things like MongoDB were even invented. Okay, so to get into this world, we kind of have to learn a new language. But don't worry, it's pretty simple. What you used to call a table, now it's a collection. A row, that's a document. And a column is just a field. But here's the key thing. This isn't just about swapping out words. It's a whole different way of thinking about how your data is structured. And that leads us right to the heart of it all, the real magic of MongoDB, the document data model. This is seriously the aha moment for most people. The idea is so simple, but it's incredibly powerful. Instead of chopping your data up into little pieces, you just keep it all together. All the related info all in one place. Right, so what does that even mean? Document-oriented. Well, the key thing to get is that it stores data in a way that looks and feels almost exactly like a JSON object. And if you're a web developer, you're using JSON every single day. So what does this mean for you? It means the data in your application can look pretty much identical to the data you're storing. No more weird translation layer. That is a huge deal. And look at this. This example just nails it. You've got one single document that holds everything you need to know about Ali. You've got the simple stuff like name and age. Then, boom, an array for his skills. And look, even a nested object for his address. It's all right there in one self-contained package. Think about what this means. No more painful, complex database joins just to get a full picture of a user. It's all there. Okay, here's another superpower, and this one is huge. The flexible schema. You know how in a traditional database, every single row has to have the exact same columns? No exceptions? Well, with MongoDB, not so much. One user document could have a field for a Twitter handle, and another one just doesn't. You can add new fields whenever you want as your app grows. No more dreaded, painful database migrations. For teams moving fast, this is an absolute lifesaver. So you might be wondering what's going on under the hood. MongoDB actually uses something called BSON, which stands for Binary JSON. Really, all you gotta know is that it's like JSON, but on steroids. It's a binary version that's way faster for the computer to parse, and it adds support for more data types, like proper date objects. It's all about squeezing out every last drop of performance and efficiency. Okay, great. So we get how the data is stored, but storing data is pretty useless if you can't get it back out again, right? Or do cool things with it. So let's talk about that. How do you actually find and process your data in MongoDB? Well, the good news is finding your data is actually really intuitive. It feels natural. You can just filter a whole collection to find exactly what you're looking for. Like here, we're just asking for all the users where the age is greater than or equal to 25. The whole query language feels a lot like writing JavaScript, which is why developers tend to pick it up so fast. But what if you need to do something more complex than just finding stuff? For that, MongoDB gives you this incredibly powerful tool called the aggregation pipeline. The best way to think about it is like a data assembly line. Your documents go in one end, and then they pass through a series of stages. So step 1, you might $match to filter for just the documents you want. Step 2, you could $group them together and do some calculations. And step 3, you $sort the final results. It's a fantastic way to do some really heavy data processing right there in the database itself. All right, let's zoom out a bit. The document model is awesome for developers, for sure. But what makes MongoDB ready for the big leagues? For these massive, mission-critical apps? Well, it really boils down to two huge concepts: high availability and scaling. So first, let's talk about keeping your app from ever going down. That's where replica sets come in. The idea is pretty brilliant in its simplicity. You have one main server, the primary, that handles all the writes. But then you have a bunch of secondary servers that are just constantly making copies of the primary. If that primary server ever, trips over a power cord and goes offline, one of the secondaries automatically gets promoted to be the new primary. And the result? Your app just keeps on chugging along, no downtime.
But what happens when you have so much data that even one gigantic server can't handle it? Well, that's where sharding enters the picture. This is MongoDB's secret to what we call horizontal scaling. Instead of trying to buy one single ridiculously expensive super server, you just add more regular, cheaper machines. The database is smart enough to chop up your data and spread it across all these machines, or shards, and then this query router, Mongoose, makes sure every request goes to the right spot. It's genius. And what's the end result of all that? This, the ability to scale to almost unbelievable sizes. We're not just talking about gigabytes or even terabytes anymore. We're talking about petabytes of data. This architecture is exactly how MongoDB is able to power some of the absolute biggest applications in the world.
So all this theory is fantastic, but let's get practical. Let's bring it back down to earth. When should you actually choose MongoDB for your next project? Where does this thing really, truly shine out there in the real world? Okay, MongoDB is a total rock star anywhere you need a combination of speed and flexibility. So think about things like high-traffic applications, backends for your microservices that are already spitting out JSON, real-time analytics dashboards, or just sucking in massive streams of data from IoT devices and logs. For all of those jobs, the document model is just a perfect match.
But hey, let's be fair. No single database is the magic bullet for every problem. It's all about using the right tool for the right job. So if your data is super relational, really interconnected, and you find yourself needing to do tons of complex joins across dozens of tables, a classic relational database is probably still the way to go. MongoDB can do joins, but it's just not its main strength. So at the end of the day, MongoDB is more than just a piece of tech. It's a fundamental shift in how we think about data. It's a model that just aligns so much more naturally with the way we actually build apps today. It gives developers flexibility, and it offers just insane scale. So the real question to ask yourself is this: is your next big idea built for documents?